It's one of the strangest unsolved puzzles in engineering. Europe and Africa sit just 8 miles apart at the Strait of Gibraltar. On a clear day, you can stand on the coast of Spain and literally see the mountains of Morocco across the water. And yet, despite being closer than many cities within the same country, no bridge has ever been built to connect the two continents. Why? After all, we've built bridges more than 7 times longer in places far less important. We've tunneled under oceans and raised highways across endless stretches of sea. So why not here? The truth is that the story of the Strait of Gibraltar is not just about engineering. It's about money, politics, earthquakes, unstable earth, and ships so massive that even a single bridge could block the arteries of global trade. At its narrowest, between Point Meroqui in Spain and Point Ceres in Morocco, the Strait of Gibraltar pinches to just over 8 miles, about 13 kilometers. People drive farther to get groceries. Yet this slim blue ribbon is the only natural doorway between the Mediterranean Sea and the Atlantic Ocean. For thousands of years, it has been the funnel where empires passed, a place the Greeks and Romans called the Pillars of Hercules. The average depth along the channel is roughly 1,200 feet, about 365 meters, deep enough to swallow skyscrapers laid on their sides, short on distance, long on depth, and absolutely critical to commerce. That mix is the first hint at why a simple bridge isn't simple at all. But the real friction starts with traffic, more of it than nearly anywhere else on Earth. More than 100,000 vessels thread this waterway every year. To put that in perspective, the Panama Canal sees around 14,000 transits annually. The Suez Canal gets close to 20,000. The Strait of Gibraltar dwarfs them both in raw ship count because it isn't a canal with locks and queues. It's an open artery connecting continents. And the cargo isn't just toys and TVs. Over 300 tankers a day carry crude and refined products. On a heavy day, the flow of oil alone coursing through this pass can reach the equivalent of 2.4 billion gallons, nearly triple what the entire United States consumes in the same period. Add liquefied natural gas, grain, cars, bulk minerals, and electronics, and you get the picture. This narrow lane is a cash machine for both shores. No surprise then that ports on either side have boomed. Spain's port of Algeciras is among Europe's giants. Morocco's Tangier Med has become an African powerhouse, with new terminals rising like glass and steel reefs along the coast. Here's the catch. All that money relies on ships moving freely. Anything that slows or funnels that flow has to fight not just engineering limits, but economic gravity. And a bridge would do exactly that, unless it's built to clear the monsters sailing underneath. Let's say politicians greenlight the dream. The price tag? Estimates range from $5 to $20 billion before the inevitable overruns that mega projects treat like a birthright. Now ask the next question. Who benefits enough to cut that check? Ferries already carry around 5 million passengers a year between Spain and Morocco. Planes make the hop in under an hour. Trucking is fast when you're dealing with short distances on land, but for heavy cargo, ships are still king. Cheaper per ton, more flexible, less fussy. The Channel Tunnel between Britain and France cost about $14.5 billion and serves roughly 20 million passengers annually. The Gibraltar corridor doesn't have anything like that demand waiting quietly in the wings. Cargo is the same story. Rolling containers off ships to drive them across a bridge and back onto ships would add time, labor, and money to trips that are already optimized. Spain and Morocco share a border of water, but not always a meeting of minds. Their history is a braid of commerce and conflict, stretching back centuries. Add Gibraltar, a British overseas territory carved out in the early 1700s and still proudly British, to the mix, and you enter the realm of diplomatic sandpaper. Who pays? Who owns the tolls? Who controls security? Where does the road connect on each side? And who gets the construction jobs? These are not small questions. They're nation-shaping decisions, and each answer creates winners and losers. Cooperation happens when both sides can promise their voters a win. And so the idea keeps meeting the same wall. Let's say, though, that both countries sign on, the financing clears, and the ribbon-cutting date is set. Engineers still have to build the thing. That's where the romance ends. We've built longer bridges. Length isn't the villain here. The strait has to stay navigable for the largest ships on Earth, vessels so tall that their stacked containers make them look like floating skylines. The Evergreen A-class can carry about 24,000 TEUs and towers more than 100 feet above the waterline. And designers know the trend line: bigger ships, taller stacks, higher demands. A drawbridge? Forget it. With traffic at this scale, the bridge would be open more than it was closed. Drivers would lose their minds, and the economies on both ends would revolt. So you need a fixed span crossing high enough to let giants glide beneath. That means huge main spans, soaring pylons, and long approach ramps so vehicles don't climb cliffs just to get on the deck. Every meter of height multiplies cost and complexity. Every meter of depth complicates foundations, and this water is deep. Look under the Strait of Gibraltar, and you won't just find water. You'll find the meeting line of two plates of the planet's crust, the Eurasian and the African. Their handshake is the Azores-Gibraltar Transform Fault, a boundary that loves to release energy at inconvenient times. This region has a memory of catastrophe. In 1755, an earthquake between magnitude 8.5 and 9.0 tore through the Atlantic floor and sent shockwaves across Portugal, Spain, and Morocco. In 1960, a magnitude 5.7 quake devastated the Moroccan city of Agadir. Seismologists don't ask if in this neighborhood. They ask when and how big. For a bridge, modern suspension bridges bend and flex. They're not stone monoliths, but they still need stable anchor points, predictable loads, and foundations that won't liquefy when the ground shudders. Build across a fault, and you accept that one day the fault will move. That movement has to go somewhere, into the cables, the towers, the deck, or the ground itself. If that were the only geologic complication, maybe there would be a path forward. Unfortunately, the seafloor here throws one more sucker punch. When geologists mapped the seabed of the strait, they found deep channels filled with quaternary clay, soft, unconsolidated, and prone to shifting under pressure. Think of trying to anchor a skyscraper in pudding. Even if you can get piles down to something firmer, the overlying layers can creep, slump, or fail, especially when shaken by earthquakes or hammered by currents. The design space narrows until you're left with options that look like science fiction, and price tags to match, which leads people to a different idea. If you can't go over, can you go under? On paper, a tunnel solves the ship problem. No need to worry about mast clearance for the next generation of megaships. Trains could shoot beneath the water like they do under the English Channel, linking two continents in minutes. But the rock doesn't cooperate. Those same clay channels that scare bridge engineers also terrify tunnel planners. Soft ground plus high pressure plus seismic risk is a cocktail that makes risk assessors reach for red pens. You can add ground freezing, pressure-balanced tunnel boring machines, and creative linings to the playbook, but you can't change the fundamentals. This ground wants to move. Even if you solved the geology, you'd still have the politics and the money to contend with. Tunnels are stunning feats of engineering, and they're not cheap. If the ferry plus plane ecosystem already meets demand at a lower cost with fewer risks, the case for a tunnel becomes more romance than reality. For now, anyway. And if you zoom out a little further, you see something else. The strait isn't only a problem to solve, it's a system to protect. The edges of this water once held Neanderthals. Later they hosted Phoenician traders, Roman fleets, and Carthaginian ambitions. As empires rose and fell, this thin blue line decided the pace of conquest and the flow of wealth. Whoever controlled it gained a lever over half the known world. Spain and Morocco's story across the strait is long and complicated. Sieges, dynasties, alliances, betrayals. Then Europe's age of colonial expansion brought new flags to old shores. Among them, the British took Gibraltar in 1704 during the War of the Spanish Succession and secured it by treaty in 1713. Centuries later, it remains a British overseas territory, tiny in size, massive in symbolism. For Spain, Gibraltar is a reminder of loss. For Britain, it's a strategic keystone. For Gibraltarians, about 32,000 people, it's home, with its own identity, its own dialect, and its own vote, which during Brexit overwhelmingly favored staying in the European European Union. None of that screams easy partner talks when it's time to ink a trilateral megaproject. If the equation is so lopsided today, what could ever change it? Start with demand. A genuine surge in cross-strait travel, say a high-speed rail corridor linking Casablanca to Madrid and into the wider European network, could rewrite the business case. If millions more commuters and tourists wanted a fast, weatherproof crossing every year, ticket sales might begin to shoulder the cost. Second, think policy. If the European Union and the African Union treated a fixed link as a flagship integration project with long-term financing, shared toll revenue, and harmonized security protocols, the funding picture could change as well. Technology could help too. New materials with higher strength-to-weight ratios, smarter seismic isolation systems, and adaptive cable damping could make extreme spans safer. Modular floating foundations, less dependent on deep anchoring, might slip over poor soils where traditional piles fail. Even hybrid ideas, like artificial islands serving as mid-channel anchors and logistics hubs, sometimes appear on optimistic whiteboards. Yet each solution solves one problem while aggravating another. Islands alter currents and habitats, floats must ride out Atlantic storms, and anything anchored still has to reckon with shaking ground. There's also a quieter, near-term path. Upgrade what already works. Faster, greener ferries, integrated ticketing that stitches ferries, buses, and trains into one click, streamlined customs and freight pre-clearance, and port expansions that treat the strait like an airport hub rather than a bottleneck. Those changes don't make headlines, but they move people and products right now. But that wasn't the whole story. Could we build a bridge between Europe and Africa? In a laboratory of pure possibility, yes, but the Strait of Gibraltar doesn't live in the lab. It lives in the real world, an earthquake zone with a restless seabed and a river of ships that must not be slowed. It lives between governments that don't always agree and budgets that want proof of payback before the first bolt is bought. It lives in a context where the cheapest, safest, most scalable option for now is the one we already use. Ships above, planes above, ferries across. So the world keeps staring across 8 miles of water, dreaming about steel and concrete where there's only blue. The idea isn't dead. It never will be. Every few years, it resurfaces with a new rendering and a fresh pitch deck. And maybe one day, a new material, a new financing model, or a rare political alignment will flip the equation. Until then, the Strait of Gibraltar remains what it has always been. A gate between seas, a nexus of trade, and a reminder that some distances are measured in more than miles. Sometimes the shortest line on the map hides the deepest set of problems, and sometimes the smartest thing to build is not a bridge, but a better understanding of why it isn't there yet.